Hi, so what I'd like to do here is to show you how, if we have the concentrations at different times of a reactant, we can figure out what the rate law is. And the easiest way to do this, turns out, is to use Excel. You can hand graph these as well. So over here, I have the concentration time and the concentrations, and I need to put in units here just to be clear. And what I'm going to do is I'm going to highlight this and go into insert and then do an XY scatter plot. It is important that you do a scatter plot. Again, there are differences between different versions of Excel or different packages, but you could probably figure it out. So I'm going to do a scatter plot, and here we have it. For this purpose, it is absolutely important that you spread the points out as much as you can within reason. So I'm going to actually to do this. What I do is I double click on the axis to go to format axis, and I change it to, so my minimum was 0.0038, so I'm going to go with minimum 0.0035 and 0.01. So that should hopefully be good enough. So this is 0th order, and I'm going to put in my axis titles, by double clicking right on it. I can actually improve this by using subscripts and so on, but right now I don't need to. And see how this doesn't fit in around the straight line. So it's not a 0th order reaction because this is concentration versus time. This is a 0th order graph. Let me just put a axis title, a chart title to this. So for first order is ln of the concentration, and what I can do is put equals to ln and then brackets and then reference the concentration value, and that would automatically calculate the natural log of the concentration. And I can fill this down and Control D, and it calculates all that automatically according to the data we have. And again, I plot a scatter plot, and this is where I absolutely have to fix the axes. So this is, the maximum is minus 4.6, and the minimum should be about minus 5.6. That'll work. I'll change the way that it's laid out here, and again just label these. Note that ln of anything has no units. And again, you see that it doesn't fit the straight line. So we know now that this is not a first order reaction either. To confirm it's a second order reaction, to see if it's a second order reaction, I do, remember this is what comes from the integrated rate laws. I do the reciprocal 1 over the concentration, and again I can use Excel to do that. And then when I do that, I highlight the numbers here, insert a scatter plot, and I can move this up here. I'm just going to move some things around so that I get what I need. And you can see now that it fits very well, the data. Again, I'm just going to spread the points as much as I can. And what I have to do now, so this shows me that it's a second order rate law, and if I go to right click on the best fit line, the trend line, and go format trend line, I can say display equation, display R squared value on the chart, and this gives you the equation for the line. So y is equal to mx plus b, and the slope is 0.54. And since this is my slope, this would be my rate constant for 3-1, and it's second order based on this graph.